Hi everyone, this is Ms. Cave with a review of theoretical and experimental probability. First of all, the difference between the two. Theoretical probability is what you think will happen, where experimental probability is what actually did happen. So when you're given problems on probability, you're either going to be given a table or... Ms. Cave, can you... So for experimental probability, it's usually some type of table or it tells you what happened. And for theoretical, it's what's in a pie chart or a spinner or dice. So you will be given questions like the first one. What is the probability that Malachi will spin a black on the next spin? So this is theoretically. So is this theoretical or experimental? Okay, because it's about the future, it's what will happen. So the probability that he'll spin a black on the next spin would be, you're going to look over here, it's 1 out of 10, which is 1 black out of 10 slices. So this on the left side is going to be your theoretical probability. So if I'm looking for theoretical, I'm going to look at the spinner. Okay, over here, what's the experimental probability that Malachi will spin a purple? So experimental of purple, okay, it's what has already happened. So you look at the number of times from the table that he spun a purple, and it's 10. So it's 10. And then you get the total number of times that he spun. So that's our 24. And then you guys are going to simplify your fraction. You divide them both by 2, you get 5/12. So that's a quick review of the difference between theoretical and experimental probabilities. Any questions on that? All right. And then down here, just to remember, as you increase the number of spins, the experimental probability will be closer to the theoretical. That's that law of large numbers we talked about. As we increase the number of spins, it's going to get closer. So what I would like you to do now is make sure that you have the 4 questions at the bottom completed. I want you to look them over. You can compare them in your group. And then we will resume the video and go over it in just a second. All right, let's look at the questions down here. So number 1, Keith recorded the outcomes he got when he flipped a fair coin 40 times. He flips the same coin 400 more times, and he should expect, so what's happening is you're going from 40 to 400, and he should expect for these 4 flips, it should be close to 200, okay? The reason for that is as you increase the number of trials, your theoretical and experimental probabilities are going to get closer. So we know that theoretically, with a coin, theoretically, it's going to be 50%, okay? Right now, it's not 50% of heads up. So out of 400, what would be 50% of 400? What's half of 400? 200. So that would be half. So theoretical probability, it should be half. So you're looking at the ones out of 400 that would be half, and that would be 200 out of 400. So it's getting close to that halfway mark. It's like when we looked at the graph on the smartboard and I showed you guys as we increase the number of trials, the 2 lines, the blue line and the green line, that represent theoretical and experimental probability, they got closer. Okay, let's go over to number 2. Penelope picks 1 marble at a time from a bag and replaces it. She repeats this process 100 times and she records the results in the table. So that 100 is important because it's asking for experimental probability. So you're looking at what actually will happen. So which color has an experimental probability of 7 out of 25? So for that, what you have to do is change each of these. So you have 28 over 100, 14 over 100, 56 over 100, and 2 out of 100. Okay? So notice that there is no 7 out of 25. So what you have to do is do a couple of things. This is what I would suggest if you guys are having trouble changing your fraction to a decimal, or excuse me, reducing your fractions. What you can do is get the decimal for each of these and compare them. So if you're not sure how to reduce that, I'm going to take 7 out of 25 on my calculator. So you can do 7 divided by 25 and see what percent it is. It's 28%. Okay? So this is, you're looking for one that's 28%. So if that's 28%, well, that's pretty easy to see, right? 28 out of 100, that's 28% as well. Now if you check these others, like this is 14%, right? Because 14 out of 100 is 14%. This is 56%, and this is 2%. This is already out of 100, so I don't even need to use my calculator. I can just change them to percents. What you can do, though, is do 7 divided by 25, multiply by 100 to get the percent. Or you can change it to hundredths. So you can see that the answer for this one is red. Red is the one that's at 28 out of 100, or 7 out of 25. Make sense? Yes? Okay. Number 3. The spinner has 6 equal sections. The arrow is spun 50 times on 35 out of 50. So this time they're giving you the information in the problem, so you've got to pick it out. It's not in a table, it's in the problem. They're telling you what happened. And you're looking for the experimental probability of it landing on a multiple of 5. So you're going to look at your spinner. There are 3 numbers that are a multiple of 5, right? But actually, if I look at the spinner, what kind of probability is that? What kind of probability would be if I look, it'd be 1/2, right? So if you looked at the spinner, you would have picked C. Why is C the incorrect answer? Is it asking for theoretical probability? It's asking for experimental. So you don't even care about the spinner. You don't even care. You don't need it because it's asking for experimental. The information that you do need is right here in the problem. That 35 out of 50 is going to be your answer. And if you reduce this, you divide both by 5, which is 7 over 10. So the answer is B. Again, if you're not sure how to reduce the fraction, you can change each of these fractions to decimals and then change 35 to 50 to decimals and see which ones are the same. That's another strategy you can use if you're having difficulty reducing the fractions, or excuse me, simplifying the fractions. Just be careful. You're going to be given experimental and theoretical together, and you need to pick the right one. Okay, the last one, number 4. It says a fair number cube is rolled 18 times. The 3 is rolled 6 times. Which statement best represents the experimental and the theoretical? Okay, so this time you're looking for theoretical and experimental. So I'm going to compare them. So first I'm going to calculate theoretical, then I'm going to calculate experimental. So theoretical is based on the cubes. So how many numbers are on the cube? 6. How many numbers are 3? So theoretically is 1 out of 6 because there's 1, 3, and there's 6 sides to the dice. So theoretically it's that. Experimental, it tells us that the 3 is rolled 6 times. So experimental, it's going to be 6 out of how many times it's rolled? 18. And then I'm going to simplify that. I can divide them both by 6, and I get 1/3. So my theoretical is 1/6, and my experimental is 1/3. So the best answer choice here is B. Any questions on probability? Okay, we're going to go now to 7.5, which you were supposed to have completed for today. 7.5 is you started it in class. We filled in the top in class. So we talked about the difference between similar and congruent sides. And now we're going to look at the answers on the bottom. So you were to finish this yesterday. So I'm going to go ahead and push this down and allow you guys time to check your answers. So number 1, if triangle ABC is similar to PQR, which proportion can be used? A helpful thing to do with these is to highlight the matching sides, the corresponding sides. So this side goes with this side. And you guys will be given highlighters during the SOL test, but you'll have to redraw them on your paper. I think you even have a highlighter in your tools. So what I'm doing is I'm just identifying all the sides that match up, looking for a different color. And then I'm just going to circle this one. And the 4 goes with the 12. Okay, so if I look at this, the one that's correct is 4 is to 9, because this yellow is to pink. The yellow is to pink. And then is the 12 yellow too? Yes, the 12 is yellow. Wait a second. The 12, no, this is a circled one. See how the 4 and 12 are circled? Sorry, that's not highlighted. It should be the 4 is to 12, those two short sides, as the 9 is to N. So those are the ones that match up in your proportion. The second one, what is the measure of angle P? Here's an important information. Angles of similar shapes are what? What is that word that means the same? Congruent. That means they're the same. So if you look at this, you know that I goes with P. Okay? And let's see. It looks like H goes with L. And K goes with M. And then J goes with N. So it's asking you the angle measure of P. P goes with I, right? So if P goes with I, P is also the same as I, which is 80 degrees. Okay, number 3, which pair of segments are corresponding sides of the triangle? Again, you can use a highlighter or something like that. So I know that FG goes with XY, and it looks to me like FH goes with ZX. And then my third side there, I'm just going to use my blue. Okay, so that's a helpful tool. And so I can look and see which ones go together. XY goes with FG. Okay, you can see they're both yellow. HG, which is blue, goes with YZ. They're both blue. And then ZX is pink and FH is pink. So you're just matching corresponding sides. This has been flipped, but it also, remember the other way you can do it? By looking at the letters. Take a look at this. You see how the letters are lined up? So ZY, which is, let's see, ZY, which is yellow. See how the ZY goes with FG? It's right here too. So you can look at the shape, and you can also look at the naming of the triangle to figure those out. Questions on that? All right. Number 4. The following is true about similar triangles ABC and DEF. Again, AB is to BC as DE is to EF. AC is to DF. So if they have a 1/2 relationship, you're going to look down here and see which one also has a 1/2 relationship. So the answer is B. And why is that? Because 3/6 is equal to 1/2. So you're looking for a relationship between the side lengths that is the same as the one that's given up here. Questions on that? All right, and we have 2 more I want to go through. 7/6. 7/6 is quadrilaterals. Yes, no, I didn't. You should be able to see. And I'll put it up while you guys work on it. We'll go through this together. So I'm going to go ahead and pause the video for a minute and just let you guys copy this down at the top. Okay, notice I have crossed out kite and right trapezoid because you guys don't necessarily, it's good information, but it's not in our curriculum. So you filled all this in. And then now let's look at the bottom. So we have quadrilateral. A basic quadrilateral has 4 sides and angles. It looks like that. You can skip kite if you want. Go on to trapezoid. A trapezoid has 1 set of parallel sides. So it has, and the key word here is exactly 1 set. Because parallelograms have 1 set of parallel sides. They actually have 2, but they have at least 1. So trapezoid has exactly 1 set of parallel sides. Parallelograms have 2 pairs of parallel sides. And remember, parallel, these symbols mean parallel. So those are the symbols for parallel. And then they also have 2 pairs of congruent sides. So that was this. You have these little lines that mean congruent. So like on the trapezoid, these 2 are congruent, these 2 are congruent. Not the trapezoid, excuse me, the parallelogram. And also notice that angles that are congruent, like opposite angles are congruent. So this angle is congruent to this angle, just like this angle is congruent to this angle. That's congruent angles. A rectangle has 4 right angles, which we see by the little square. It has 2 sets of opposite congruent sides, so let's put that in. Oh, it's got it here. You've got your 2 congruent sides, 2 pairs, and we also have 2 pairs of parallel sides. And a rhombus has 4 congruent sides, so it has all those things. It has 2 pairs of parallel sides, 4 congruent sides, 2 pairs of congruent angles. And then a square has 4 right angles and 4 congruent sides. So remember, a square is also a rhombus, it's a rectangle, and it's a parallelogram. So real quickly, I'm going to pull this down for just a second so you guys can see up here. I want to emphasize this. So a square is inside all of that. So a square is a rectangle, a rhombus, a parallelogram, and a quadrilateral. A rectangle is a parallelogram and a quadrilateral, and a rhombus is a parallelogram and quadrilateral. A trapezoid is not any of these things. So remember, your Venn diagram looked a little different. It was just turned. It was the same thing we did in class. Ours was just turned this way. It's the same thing that we did before. The only thing added in this packet was a kite. So any questions on this part? Once you've finished copying this down, go ahead and do the back and complete those questions. All right, now that you've had a few minutes to complete the questions on the back, please go through and check your answers. Number 1, which property is common to all quadrilaterals? All quadrilaterals have 4 angles. Number 2, what this shape here is all of these things. It's a quadrilateral because it has 4 sides. It's a parallelogram because it has 2 pairs of parallel sides, 2 pairs of congruent sides, and it's a rectangle. It's not a square because it doesn't have 4 congruent sides. Number 3, if a polygon has all congruent sides, it's most likely a rhombus, okay? It could be a square, but it would also need to have 4 right angles. If it has 4 congruent sides, it's definitely a rhombus, because remember, a square is a rhombus, but it's only a square if it has 4 right angles. Number 4, which statement is false? All rhombuses are not squares, because remember, squares have to have 90-degree angles, and rhombuses do not. Number 6, every parallelogram is also a quadrilateral, because all parallelograms have 4 sides and 4 angles. Number 7, this shape here, it is, okay, so the things that it is, it's asking what it's not. It is a quadrilateral, it is a parallelogram, it is a rhombus. It is not a square because it doesn't have 4 congruent, or because it doesn't have 4 90-degree angles. It's not a rectangle because it doesn't have 4 90-degree angles, and it's definitely not a trapezoid. Okay, back up here to number 5. Which classifications appear to describe both of these figures? This is a parallelogram and that's a rhombus. So both parallelograms and rhombi are parallelograms and quadrilaterals. See, this doesn't fit, although rhombus fits in the rhombus category, parallelogram does not. And neither one of those are rectangles, trapezoids, or squares. Number 8, select each property that is true for any rectangle. There are exactly 2 pairs of parallel sides. There are exactly 4 right angles. There are exactly 2 pairs of congruent opposite sides, and there are exactly 4 congruent angles. This would be what shape? There's exactly 1 pair of parallel sides. That's a trapezoid. There are exactly 4 congruent sides. That could be a rhombus, but it's not, or a square, but it's not true for all, or for rectangles. There are exactly 2 pairs of congruent opposite angles. There are exactly 2 pairs. I would highlight that one. Don't you guys think? A rectangle has 2 pairs of congruent opposite angles? I would say yes, there was a mistake here. Let's go ahead and highlight that one. So that's actually a true one. Okay. And then at the bottom, use your knowledge to solve these practical problems. Felicia knows the measure of one angle of her rhombus. What are the other angle measures? So if she knows that this is 75, okay, sum of angle measures is 3, remember 360 is the total. So if this is 75, P is also 75 because you can see that opposite angles are congruent. And then to get 360, or to get the other angles, you subtract 150, which is 75 plus 75, and you get 210, right? So that means these 2 angles are 210. You divide that by 2, and so each of those is going to be 105. If the perimeter of a square is 52 inches, what is the length of one side? A square has 4 sides. So if the perimeter is 52, we simply divide by 4 to get each of the side lengths. So the answer is 13. Given the measurements of this isosceles trapezoid, meaning that 2 sides are congruent, what is the measurement of OG? It would be the same as DS. So the answer is 7. And then for number 4, the length of LO is 2. These are diagonals. What is the length of PA? It would be 4 because going all the way across, if this is 2, all the way across is 4. And remember, rectangles, diagonals bisect each other and they're congruent. Okay? Questions on quads. So you've got the sheet, and you guys also have the sheet I just gave you. So you can turn to, just to give you an example, you can go to 7.6. I know it's small. It came out kind of small, but look, here's your 7.6 study guide. It goes over everything again. I know it's hard to read these. It says quadrilaterals, parallelogram, trapezoid, but you can kind of see them if you squint. So this is going to be helpful to you guys if you get stuck. This is really important here. Sum of angle measures is 360. Thank you guys. You're doing great listening today. I know it's a lot, but I want to get through these pages so next week you guys can really just work on all the problems. So let's go to 7, what was this, 7.6? We only have one more to do. So we're going to transformations. Transformations. You don't have to write everything there. Let's talk about what it is. A translation, I'm just going to highlight what you need to write. A transformation, we have 2 different types. We have reflection and translation. This is in your extra pages. This was given to you in your extra pages because it didn't print out nicely on your original copy. So go to your packet where you stapled the extra pages to it and find 7-7. So a translation is a slide. And the image should be, you guys can just write down same size and same direction. You don't have to write everything there. Horizontal means right or left, which is plus or minus. Vertical means up or down, which plus for up, minus for down, or positive for up, negative for down. So my example, if you look here, if I'm translating vertically 4, I take each of my points. I'm going to go up 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and plot the points. And remember, we're going to use that symbol there to indicate that it's not the original, it's an image. Reflection is a flip across the axis. The image should be the same size, but it's going to face a new direction. So what I want you guys to at least write down, you can write it all if you want, or just what I've highlighted. So if it goes over the X, it's going to go up or down. If it goes over the Y, it's going to go left or right. So you notice that this says reflect over the Y axis. So what you do is you look at the distance, and we just did this in the last unit. So since D is 1 away from the Y, and remember another tip is to highlight the axis that you're reflecting over. So if D is 1 to the right, D prime is 1 to the left. If S is 3 to the right, S prime is 3 to the left. And notice that A stays where it is because it's on the line of reflection. So go ahead and do the examples here. And so you have 4 practice problems at the bottom. So you're going to complete those 4 problems. This was actually one I assigned you guys for homework. So I'm going to go ahead and show the answers to you so that you can correct yours. I know some people are still writing. So again, when you guys do your assessment today, assessment 3, you can use your packet, you can use your study guide. What you can't do is talk to others about it. Now, are you going to be able to use your packet and your study guide in your SOL test? No, but right now I want you looking at it as a resource. And so we're going to push this up. So if you see these questions, the first one, LMNP reflected across the Y. So if it's going across the Y axis, that means it's going, we're looking for the coordinates for M, so it's going to go over here. So M was 2 from the axis here, so it's going to be 2 on the other side. So you plot your point. It's on the other side, and my X value there is -2, and my Y value there is -5. Number 2, the new coordinates after this is translated left and then reflected. This is a little trickier. You're translated, and we're looking for N. So I'm just going to take N, and I'm going to go 1, 2, 3, 4. That's my translating of 4 units to the left, -4. And then I'm reflecting over what axis? The x-axis. So I'm reflecting that point over the x. So you can see that the original was 1, 2, 3. So the new one is going to be 1, 2, 3 above. So your coordinate there would be -2 on your x and 3 on your y. And then number 3 and 4. Number 3, you're translating ABC horizontally 5, and you're getting the coordinates for B. So since it's only asking for 1 point, you only have to translate at 1 point. So I'm taking B and I'm going horizontal. So I'm going to go over 1, 2, 3, 4, 5. So my B prime value is -2, -2. My x is -2, my y is -2. And then the last one, draw the image of LMN after a translation horizontally -5 and vertically -5. So you're taking each point, so starting with L, you're going to go -1, and then you're going to go -5 down. 1, 2, 3, 4, 5. And then you place your L prime. You're going to do that for each of your points and label your vertices. So this is your original, it doesn't have the prime symbols, and then that is your image. So go ahead and finish copying these down, making sure you understand. And then we'll do assessment 3. Are there any questions on transformations? Again, may I? You have in your study guide for transformations that you can refer to, the sheet I gave you today, 7.7 in your study guide. It gives you examples of a translation, and it also gives you examples of a reflection. Okay, that's it for our study guide review today.